All right, so here is the test review. So let's go and go through this. So the first one says to rewrite the expression using rational exponent notation. So the radicand, the number inside the radical, is your base. You're going to raise it to the power over the root. There's no power here, so we know it's a 1. And we divide it by the root 3. All right, so this one right here, our base is 11. That's the radicand. And we put power over root. So the power is 7 over the root, or the index, which is 8. This one, negative 21. The radicand is a base, power over the root, so 3 over 7. And then for our last one here, if you'll notice, we have a negative exponent. So we know it has to move to the bottom. Since there's no number on the outside, it's a 1. So we have negative 2 raised to the power. So when you bring it to the bottom, the negative exponent becomes positive over the index of the root, which is 9. All right. Let's go ahead and take a look at the next one. Number 5. So here it says to write it in radical notation. So it's the previous one over here. So, maybe I should put this, the nth root of a raised to the m power. And the previous one was supposed to be a raised to the m divided by n, right? So again, this was the power. This is the index, or the root. So this is the power, and this is the root. So we start with our radical sign. Our root is the number on the bottom of the fraction, which is 3. The base is a radicand, goes inside. And we raise it to the m power. In this case is 1. So we can put a 1, or we don't need to put it. It's your choice. So again, this one, radical sign. The root is 5. The radicand is negative 28. And that's going to be raised to the 7th power. So 7 is the root. 39 is the radicand, raised to the 4th power. And you'll notice this one has a negative exponent, so we do need to move it to the bottom. There's no number on the outside, so we put 1 over. So here's our radical sign. The 6th root, radicand is 32, and our power is the 5th power. Notice it is positive now because when we moved it to the bottom, the exponent that was negative became positive. All right, so for number 9, it says to evaluate the following, round to 3 decimal places when appropriate. All right, so we're just going to go ahead and put parentheses 36, close parentheses. To raise it to the power of 3/2, we press the little caret. I like to do n over d, and I'm going to raise it 3 over 2, and hit enter, and we get 216. For the next one, same thing. I like to use parentheses, 4, close parentheses, caret, negative n over d, 5 over 2. And I get 1 over 32. For number 11, same process. Oh, actually different. Parentheses. Now this one, the cube root, you're going to put the 3 first, then second caret, and that makes the 3 a root. So cube root, negative 96, arrow out, close parentheses. Then it's squared, so there's x squared right there. There we have it. Hit enter. And we're going to round this to 3 decimal places, so 20.9659, which would be 20.966. All right. And for the last one here, 96 to the negative 2/3, so parentheses, 96 raised to the negative n over d, 2/3. And 0.0476, which would be 0.04, the 6 rounds of 7 to an 8. All right, on to the next one. It says to solve the equations, check your solution. So we're kind of looking to see if we have any extraneous solutions. All right, so for the first one, the first step we take is we're going to isolate this radical. So we're going to subtract 7 from both sides. And I know that it's an even root, it's a square root, so we got to pay attention to what we come up with. So this becomes negative square root of x minus 4 is equal to negative 13. We're still not isolated, so we're going to divide by negative 1. And we get the square root of x minus 4 is equal to negative 13 over negative 1 is positive 13. It's a positive number, so we continue solving. And x minus 4 equals 13 squared, which is 169. Let's go ahead and add the 4 to the other side. And we get x is equal to 173. Now we're going to verify this just by plugging it back in our calculator to make sure it does work. So we start with 7 minus the square root of x, which is 173, minus 4, and that does equal negative 6, so our answer checks out to be correct. All right, on to 14. So for 14, the first thing we're going to do is we're going to subtract 3 halves. And if you wanted to convert it to a decimal, you could. That's really up to you. So we have the square root of 3x plus 4. 3 minus 3 halves should be positive 3 halves. And I'm just going to verify that in the calculator. So we have 3 minus, and already 3 halves. And we get 3 halves. All right, to get rid of our square root, we're going to square both sides. And we get 3x plus 4 equals, now I'm going to square each one. 3 squared is 9. 2 squared is 4. Let's go ahead and subtract 4 from both sides. So we get 3x equals, let's see, it equals negative 7/4. And we can just verify it in the calculator real quick just to make sure it is right. So we have n over d, so 9/4 minus 4, and we get negative 7/4. Last thing we do is we divide both sides by 3. And that gives us x equals, and let's just verify this. So n over d, we have, let's do it again. So we have negative 7/4. And that's all divided by 3, which should be negative 7/12. And we're going to verify that that answer is correct. So let's go ahead and plug it in. The square root, where is it? X square root of 3, and it's going to be negative 7/12. And then we have plus 3 halves. And this should equal to 3. All right, let's see if I made a mistake somewhere. Yep, there we go. Forgot an error out of there. Oops, still a domain error. Oops, forgot the plus 4. That makes sense. There we go. Plus 4 plus 3 halves. There we go. And we do get a value of 3. Nice. So yeah, sorry about that. So be careful with these calculators. Make sure you pay attention to what you're typing in. All right, on to number 15. So again, here we're going to solve for x. It's a rational exponent. So the first thing we do is we're going to add the 3 to the other side. So we have 2 times x minus 1 raised to the 1/2 power is equal to 7 plus 3, which is 10. We're going to divide both sides by 2. And we get x minus 1 raised to the 1/2 power is equal to 5. Now this time we have this rational exponent, so we raise it to the reciprocal, and the reciprocal of 1/2 is 2/1, which is a square. So this 1/2 and the 2 multiply out to 1, so they cancel each other out. So we have x minus 1 equals 5 squared, which is 25. Last step is we're going to add the 1 to the other side. And x is equal to 26. Again, we're going to verify it just to make sure it is right. So we have 2 parentheses, and we have 26 minus 1. Try it again. Close parentheses, raised to the 1/2 minus 3. And and it should equal 7, which it does. All right. Let's keep going here. So our answer is 26. So let's take a look at 16. It's a cube root, so as long as the work is right, you don't have to check your work, but we'll verify that it does work. Subtract 1 from both sides. So we get the cube root of x is equal to -3, and that's okay because we know a cube root, odd roots, will give us one solution. We raise both sides to the third power, and the cube root and the cube cancel each other out, leaving us with x, and -3 cubed is -27. All right, and just to verify that this is correct, we'll do, so 3 second caret is the cube root of -27 plus 1, and that should give us -2, which it does. Perfect. All right, for the next one, let's go ahead and subtract 2 to the other side. And we come up with 4 cube root of x is equal to -2. Divide both sides by 4. The cube root of x is equal to -1/2. And last, to get rid of this cube root, we're going to raise both sides to the third power. We're going to cube it. And x equals, we're going to cube each one individually. -1 cubed is -1. 2 cubed is 8. Let's go ahead and verify this answer. So 4 times 3 cube root. Let's see. So yeah, let's see how I can fix that there. I'm just going to delete this, see what that does. Yeah, there we go. So 4 cube root of -1/8 plus 2. And let's see if that gives us 0, which it does. So that is our answer. Good. All right, on to 18. All right, so with 18, the first thing we do, to get rid of that cube root, we cube both sides. So we get 2x plus 7 is equal to 5 cubed is 125. We subtract 7 from both sides. So 2x is equal to 118. Divide both sides by 2. And x equals, I would say that's going to be 59. Let's verify this answer works out real quick. So we have the cube root, so it's 3 second cube root of 2 times 59 plus 7, and that does give us 5. So that answer does check out. Awesome. All right, on to our next ones here. So number 19, first we're going to add 3 to both sides. So we get 2x plus 12 raised to the 2/3 power equals 16. To get rid of this rational exponent, we raise it to the reciprocal. So the reciprocal of 2/3 is going to be 3/2. So this becomes 2x plus 12 equals, and I'm going to write this as in the radical notation. So it's the square root of 16 cubed. Now the reason for this was so you could see that 2x plus 12 equals, the square root of 16 is 4, and 4 cubed is 64, but since we took an even root, we have to put plus or minus, and 4 cubed is 64. So we're going to set up 2 equations to solve. So the first one is 2x plus 12 is equal to positive 64. 2x plus 12 is equal to negative 64. All right, so let's go ahead and solve the first one. We're going to subtract 12 from both sides. 2x is equal to 52. Divide both sides by 2. X equals 26. Other side, we're going to follow the same process. Subtract 12 from both sides. So 2x is equal to negative, 76. Divide both sides by 2. X equals negative, 38. I'm going to verify this just to make sure I didn't make any mistakes. All All right, so negative 64 minus 12 is negative 76. Divide that by 2, and we do get negative 38. Okay, so let's verify these answers. We're going to plug them into the originals. So 2, start with parentheses. Parentheses 2, parentheses, our x was 26. Close parentheses, plus 12. Close parentheses, raise it to the 2/3 power. Minus 3, and it should equal 13. So the first one checks out. Now we're going to go up here and change this to negative 38. Now when you do this one here, I can put the negative and notice it replaces a 2. If you press second delete, it actually inserts, so you can do 38, so 3. And then I want to put that as an 8. And it has a 2 divided by 3, minus 3, so I press enter. Let's see if it's 13 as well. And it is, so that means that both answers do check out, which makes sense because our root right here, if you can see, it's odd, so the answer should work. All right, on to the next one. So for this one, first thing we'll do is subtract 9 from both sides. So we have 3x plus 21 raised to the 4/3 power is equal to 81. We're going to raise it to the reciprocal, which 4/3 becomes 3/4. And we have 3x plus 21 because the 4/3 and 3/4 cancels. I'm going to write this as in my radical notation, the 4th root of 81 cubed. So 3x plus 21 equals, now the 4th root of 81 is 3, but since it's an even root, we put plus or minus. And 3 cubed is 27. So again, we'll be working out 2, so 3x plus 21 equals to 27, and 3x plus 21 is equal to negative 27. So on the first side, we'll subtract 21 from both sides. We get 3x is equal to 6. Divide both sides by 3. Our first answer is x is equal to 2. For our second one, we'll follow the same sequence, subtract 21 from both sides. 3x is equal to negative 48. Divide both sides by 3. X equals to negative 16. Again, we have an odd root at the very top, so answer should check out, but let's just verify. So for the first one, we have 3, so parentheses 3, open parentheses 2, close parentheses, plus 21, raised to the 4/3. And there's a plus 9 at the end, and it should equal 90. Oops, I see where my mistake is. That should not be a 9 right there, so we have to arrow out, and that should be plus 9. There we go. First answer is 90. Go back up here. We're going to arrow down to that 2, and we're going to change that 2 to a negative 16, so negative, then second insert, 16. And again, we get 90, so both answers do check out. All right, on to the last one for this part here, for the front. So we have a cube root equals a cube root, so there's no numbers on the outside. So what we do to get rid of this or to remove it is just cube both sides. So the cube root and the cube cancel, leaving me with 3x plus 9. Again, cube root, cube cancel, so leaving me with x plus 6. I'm going to go ahead and subtract the x to the left side. That gives me 2x plus 9 equals to 6 because the x's cancel. I'll subtract the 9 to the other side. 2x is equal to negative 3. Divide by 2. And x equals negative 3/2. And let's verify that this does work. So we have the cube root of 3 times negative 3/2. Arrow out to close parentheses, plus 9. That's what we get. And let's verify the other side is that. So the cube root of, so we have negative 3/2 plus 6. And that also gives us the same answer. So this answer does check out to be correct. All right, on to the back. Okay, so for 22, so 22 is a lengthy-ish problem, so let's go ahead and take a look at this one. So you notice the 1 is right here, and we can't get rid of both square roots, so we're just going to square both sides. So notice this is together, and so is this. So this is squared, so we're going to write it twice. The square root of x plus 1 times the square root of x plus 1. And the square and the square cancel each other out, leaving me with 3x minus 3. So for this first one, we're going to FOIL it out. We're going to do the square root of x times the square root of x, which is x. The square root of x times 1 is plus the square root of x. 1 times the square root of x is square root of x. And 1 times 1 is 1. All right, I'm going to go ahead and move the x and the 1 over by subtracting it over to the other side. And then the square root of x plus the square root of x is 2 square root of x, which is equal to, so x's cancel, 1's cancel, 3x minus x is 2x, and negative 3 minus 1 is negative 4. Divide both sides by 2. And we get the square root of x is equal to x minus 2. To remove the square root, we're going to square both sides. So this will be the square and the square cancel, x equals, this is going to be x minus 2, so it's going to actually be x minus 2 times x minus 2. So x squared minus 4x plus 4. Then we're going to go ahead and subtract this x over to the other side. And then I'm going to use a different color here because I am running out of options. So we have, let's see, we have x squared minus 5x plus 4 equals 0. So at this point here, you would have to do the x method to solve it. I'm going to factor it. So x minus 4, x minus 1 equals 0. If I set each one equal to 0, x equals 4, and x equals 1. Now we're going to check for extraneous solutions on this. So let's go ahead and plug it in. So we have the square root of our first x is 4 plus 1. And we get 3. So now we're going to do this other side, second square root of 3 times 4. Then, oops, inside minus 3. And we get 3. So our first answer checks out. Now for our second one, we're going to plug in the 1. So the square root of 1 plus 1 should be 2. And then we have the square root of 3 times 1 minus 3 is 0. So 2 and 0 are not equivalent, so that second one is extraneous. My only answer is x equals 4. All right, let's see how much room it takes to do number 23 now. All right, so for number 23, the first thing we're going to do, we're going to isolate that rational exponent. So we're going to add 2 to the other side. So we have 2x plus 1 raised to the 1/2 power is equal to 2 plus 2, which is 4. To get rid of the 1/2 power, we're going to square both sides, which is raising it to the reciprocal. So 2x plus 1 is equal to 4 squared is 16. Let's go ahead and subtract the 1 to the other side. 2x is equal to 15. Last, we'll divide by 2. And x equals 15 halves. And let's go ahead and just verify that this answer does work. All right, so we're going to go into the original. Parentheses 2 and x's parentheses 15 over 2 raised to the 1/2 minus 2, and it should equal 2, which it doesn't. So let's just verify, and I did not do this right. I'm looking at it right now. So if you notice, after the 15 halves, 1 divided by 2, but for some reason, I'm seeing that there. Let's see if that makes a difference. Nope, does not make a difference. All right, let me just verify. I want to make sure there's no mistakes here. Okay, so I did see a mistake. All right, let's try it again. Parentheses 2, open parentheses, 15 over 2, close parentheses, raised to the 1/2, arrow out, plus 1. There it is. That's where I keep messing up. Sorry about that. Plus 1, close parentheses, raise to the 1 divided by 2, minus 2, and there we go. The answer is 2. Sorry about that. So my answer is x equals 15 over 2. All right, on to the next one. First thing we do, subtract 9 from both sides. So we get negative square root of x plus 4 is equal to 4 minus 9 is negative 5. Divide both sides by negative 1. The square root of x plus 4 is equal to negative is going to be 5. To get rid of the square root, we square both sides. X plus 4 is equal to 25. Subtract the 4 to the other side. X is equal to 21. All right, let's see if I can type this one in correctly with no errors. All right, so we start with 9 minus the square root of x plus 4, so 21 plus 4. Oh, and we do get 4. So there's my answer. Now just recall, if this was a square root and equal to a negative number, not with a negative front, just like the square root equals a negative number, that would be a no solution. Let's keep going on to number 25, which is a few questions from finishing now. All right, so for this one here, I have a radical equals linear expression, so there's no way to get rid of the radical without squaring both sides. So this is the square root and square root cancel out, leaving me with 2x plus 1. And this will be 2x minus 5 times 2x minus 5. So FOIL it out, 4x squared minus 10x. Distribute negative 5. Negative 5 times 2x is negative 10x. And the negative 5 times negative 5 is positive 25. So 2x plus 1 equals 4x squared minus 20x plus 25. Since it's a quadratic function, we do have to set it equal to 0. So let's move the 2x over. And let's move the 1 over. So we get 4x squared minus 22x plus 24. Let's go and do the x method. Actually, we can divide everything by 4 first. Sorry, by 2. So let's divide everything by 2 real quick. Well, let me factor out a 2 and show you what I'm doing. I'm going to factor out a 2. So 2 goes into 4x squared twice, so 2x squared. 2 goes into there, negative 11x, and then 2 goes there 12 times, equals 0. And if I divide everything by 2, I come up with 2x squared minus 11x plus 12 is equal to 0. All right, on the top is b, which is negative 11. Divide by a, which is 2. And then a times c is 24. So factors that add to negative 11 but multiply to positive 24 will be negative 8 and negative 3. So let's see if I can fit this in here. Negative 8 divided by 2 is negative 4, so we'll do x minus 4. And this becomes 2x minus 3, set equal to 0. So x equals 4 and x equals 3 halves. Let's see if they work or if one of them is extraneous. All right. So the first one, the square root of 2 times 4 plus 1. We get 3 on this side, 2 parentheses 4 minus 5, and we get 3. So the first one checks out, x equals 4 is a solution. For the second one, second square root of 2 parentheses 3 halves plus 1. We get 2. And for the second one, 2 parentheses 3 halves minus 5. And these are not the same, so the second one's extraneous. My only solution is x equals 4. All right, let's see if we can fit this one in here. Let's take a look here. Okay, so for this one right here, for 26, first thing we do is subtract 10 from both sides. So we get 5x plus 14 raised to the 2/3 power equals negative, and this 6 minus 10 is negative 4. So we raise both sides to the reciprocal. The reciprocal of 2/3 is 3/2. And these cancel out. So we have 5x plus 14 equals, now watch what happens here. Let's see. So parentheses, -4, close parentheses, raised to the 3 divided by 2. And we get a domain error, okay? And so, let's see, I guess the reason for this is if you were to rewrite this in your radical form, the square root of -4 cubed, which is impossible to take the square root of a negative number. So this right here should be a no solution. I'm just going to verify that my work is right, even though I've written the answer. Subtract the 10, so 6 minus 10 is -4. And yeah, that looks correct. No solution because you cannot take the even root of a negative number. All right, let's take a look at number 27. First step we do is we add 5 to the other side. So we have 2 parentheses 5x squared plus 10 raised to the 2/3 is equal to 50. We want to divide both sides by 2 to isolate that parentheses. So parentheses 5x squared plus 10 raised to the 2/3 is equal to 25. We raise both sides to the reciprocal of 2/3, which is 3/2. So we get 5x squared plus 10 is equal to the square root of 25 cubed. Square root of 25 is 5. 5 cubed is 125. And I will verify this in the calculator just so y'all are sure it's correct. So the square root, parentheses, the square root of 25, arrow out, close parentheses, raised to the 3rd power, is 125. All right, from here, we're going to solve for x. So we're going to subtract 10 from the other side. We get 5x squared is equal to 115. Divide both sides by 5. So x squared is equal to 25. Square root on both sides. X equals 5 and x equals -5 because it's plus or minus 5. And let's just verify that both answers work before I say that's my answer. Okay, so for the first one, 2 parentheses 5. So we have x squared, so let's go with 5 squared. Plus 10, close parentheses, raised to the 2/3 power, minus 5. And that should be 45. And let's just make sure I didn't make any errors here because that does happen. All right, let's verify this here. So we have 2, then we have 5. This is my x squared plus 10 raised to the 2 divided by 3 minus 5, and we got 47. So the first one appears to be extraneous. Let's check the second one real quick. All right, so I'm just going to change this 5 to a -5. So negative, and once again, if you don't feel comfortable like this, just type it in. I get another 47. Okay, so I got to make sure I don't make any mistakes here. It's not something we want to do. So we're going to add the 5. We get 50. Divide by 2. 50 divided by 2 is 25. Then we raise these sides to the reciprocal. So the square root of 25 is 5. 5 cubed is 125. We subtract 10. We get 115. Divide by 5. So let's make sure 115 divided by 5 is, there it is. It's 23 actually. So always go back and double check your work. And that's a perfect example of why. 115 divided by 5 is 23. So this should have been 23 here. And when we take the square root, x should equal the square root of 23. And x should equal negative square root of 23. And let's verify that these are right first. All right, so 2 parentheses 5 second square root of 23 raised to the second power plus 10, close parentheses, raised to the 2 divided by 3, arrow out, minus 5. Syntax error. Oh, gosh. There we go. There it is right there. Boop. There we go. 45. I added an extra parentheses by accident. All right. We can go back up here. And the second one, it's a negative 23, but it's going to be in parentheses. So parentheses, second insert, negative, second square root, 23. And we're just going to erase this 23 here. And we're going to square that. So we have, oops. Let's go ahead and close parentheses. Let's go ahead and square that. Then we have a plus. All right, let's verify this is right. So 2, 5, parentheses, negative square root of 23 in parentheses, squared, plus 10, close parentheses, raised to the 2/3 minus 5, and we get 45. So both answers actually check out to be correct. All right, so once again, just always verify your answers are right. So you see a little bit of work I had to actually do there to make sure I did get it right. All right, moving on from here. These ones are going to be your inequalities. So here's how you solve them. All right, so remember, even roots, you have those steps to follow. Odd roots, whatever the answer is, that answer is final. Okay, so for the first one here, it's already isolated, and that's an even root, right? That's a square root, so it's even. Since the number is positive, we're going to continue solving it like normal. So we're going to square both sides. So we have 6x minus 5 is greater than 4 squared is 16. We're going to add 5 to the other side. So 6x is greater than 16 plus 5 is 21. Divide both sides by 6. And we get x is greater than 1 over 6 can reduce by 3, so that's going to be 7 halves. And since x is greater than 7 halves, that answer is final. All right, for the second one, again, it's already isolated, and it's an even root. This time it's less than, so we can continue to solve it because the real thing is this value here, the constant is positive, so we're going to solve it like normal. And at the end, we'll verify to see what it is. So we square both sides. So 4x plus 5 is less than or equal to 100. We subtract 5 from both sides. We get 4x is less than or equal to 95. And then we divide both sides by 4. And we get x is less than or equal to 95 over 4. And since this is less than a positive number, we have to set the radicand greater than or equal to 0. So my radicand is 4x plus 5. I'm going to set that greater than or equal to 0. So if we subtract 5, 4x is greater than or equal to negative 5. Divide by 4. X is greater than or equal to negative 5/4. So that is our lower bound. So it's going to be negative 5/4 is less than or equal to x, which is less than or equal to 95 over 4. All right, let's go ahead and take a look at number 30 now. Okay, so first we have to isolate the radicals. So we're going to subtract 3 from both sides. So the square root of 4x minus 5 is less than or equal to 7. That's a positive number. That's an even root, so we keep going like normal. Square both sides. So 4x minus 5 is less than or equal to 4 squared is 49. Let's go ahead and add the 5. So 4x is less than or equal to 49 plus 5 is 54. Divide both sides by 4. X is less than or equal to, so I'm going to reduce 54 over 4 on my calculator just to make sure I do it right, which is 13.5. So let's make that a fraction. 27 over 2. So 27 over 2. Now, once again, you verify this is a less than, so we have to find our lower bound. So we set the radicand greater than or equal to 0. So we add the 5. 4x is greater than or equal to 5. Divide by 4. And we get x is greater than or equal to 5 over 4. So we have 5 over 4 is less than or equal to x, which is less than or equal to 27 over 2. All right, on to our next problems here. So for this first one, first thing we do is we subtract 4 from both sides. So we have negative 2 square root of 2x plus 9 is greater than or equal to 6 minus 4 is 2. We divide by negative 2, and recall when you divide by a negative number, you flip the sign. So the square root of 2x plus 9 is less than or equal to negative 1. At this point here, we stop because it's an even root and it's less than a negative, which is not possible. So this should be a no solution right there. All right, on to the next problem. So we're going to solve it the same way. Now, this one's a cube root, right? All of them have been even roots, so we followed rules. The cube root, once you solve it, you're actually just done with the problem. All right, so the first thing we do, we get rid of the cube root by cubing both sides. So we have the cube root and the cube cancel out, so 4x minus 1 is less than or equal to, I don't actually know what 8 cubed is, so let's go ahead and put this in the calculator. 8 cubed is 512. We're going to go ahead and add 1 to the other side. So 4x is less than or equal to 513. Divide both sides by 4. And x is less than or equal to, now I'll verify that this is simplified. I'm pretty sure it is. But n over d is going to be 513 over 4. And that's what we get. If you want to convert that to a decimal, make sure you just round it correctly. And since it's an odd root, this is my final answer. All right, on to the last question for inequalities. So again, we have an even root. So let's go ahead and first start by squaring both sides. So we get 2x minus 3 is greater than or equal to, so we're going to square each one. 3 squared is 9, and x squared is x squared. Now, since we have a quadratic function, let's go ahead and move everything to the same side as the quadratic. So we have 0 is greater than or equal to 9x squared minus 2x plus 3. And I'm going to go ahead and flip this around. 9x squared minus 2x plus 3. And this symbol is opening towards the 0, so less than or equal to 0. We're going to do the x method. Negative 2 divided by 9. 9 times 3 is 27. So at this point here, I don't think this one is factorable. I think this x might be extra. I don't think this x is supposed to be here. But we're going to go ahead and omit this one because I don't think that x is supposed to be there. And right here, I'm not seeing any factors that add to negative 2 and multiply to 27, so we're just going to leave that one alone. All right, and for the last one here, it says to use the following information to answer questions 34 through 36. So for this here, the velocity of a free-falling object is given by this equation. V equals the square root of 2gh, where v is velocity in meters per second, g is acceleration due to gravity in meters per second squared, and h is the distance in meters the object has fallen. The value of g depends on which body / planet is attracting the object. If an object hits the surface with a velocity of 30 meters per second, from what height was it dropped in each of the following situations? Okay, so it's already automatically telling us that the velocity is 30 meters per second. So our v right there, which is velocity in meters per second, is always going to be 30 for each problem. All right, so for question 34, we'll do this one in purple. So we're going to plug in 30 for our velocity. And then we have the square root of 2, and our gravity in this one is 9.81. And then h is what we're trying to find. So when we're doing this one, we're solving it. First thing we're going to do, we're going to square both sides to get rid of the square root. 30 squared is 900. 2 times 9.81, I'm going to put that in the calculator real quick, just so I don't have to do extra step. And we get 19.62. So 19.62h. Divide both sides by 19.62. take 900 divided by 19.62. And we get this, so we're going to round it to 45.872. And this is in, assuming meters, and height in meters. There we go. So there is my first answer. All right, for the second one, we'll do this one in green. So this time we have, again, the velocity is 30 equals the square root of 2 times my gravity of 1.57 h. So the process is going to be very similar. Square both sides. Again, we get 900 equals 2 times 1.57 is, I want to say 3.14, but let's go ahead and verify that. 2 times 1.57, so 3.14 h. And then to solve for the height, we divide both sides by 3.14. And let's see, 900 divided by 3.14. And we get 286. So the height equals 286.624 meters. All right, and then we have the last one here. So again, our velocity is 30, square root, 2 times our gravity is 3.72 h. So process is very similar, square both sides. So we have 900 equals, and then 2 times 3.72 is going to be 7.44. Divide both sides by 7.44. And we get the height equals, and let's see what this is. 900 divided by 7.44, which is 120.9677, which would be 968 meters. All right, and that concludes the review.